Okay, guys, so I'm going to go over the homework for tonight, which is the first part of it is on page 10 of your packet. So I'm going to go to page 10, and I'm using Second Academics packet right now. So numbers 24, so here's page 10, and this has to do with scientific notation, exponents, irrational, rational numbers, all those things. So here, this number 24, it says which number line best represents the locations for these. So I would go ahead and use the calculator for that. So since this says 2 times pi, I'm going to use the pi button. So 2 times, and then here, pi. Okay, so that's your EXP button, and then you just press equals. Now I know that at home you don't have this calculator, but this is what it will look like. So 2 times pi, then you press equals. It comes out to be about 6.283. So I'm going to write that right here, 6.283 dot dot dot, and then square root of 38. So you take 38 and you square root that and get 6.164. Okay, so looks like since this 2 is bigger than this 1, this number is going to be a little bit before that one. Okay, so let's look for 6. Okay, these all have 6. Okay, so we're looking for 6.164. So these look a little weird, but this is 6, and then if it's 6.2, then this must be 6.1, 6.2, 6.3, 6.5, 6.7, 6.9, and then 7.0. So let's see, 6.1 is about here, here, here. All right, and then this is a little bit after the 6.16 or 6.1. So, and then 6.2 is right here. So 6.16. It will be somewhere around here-ish. So let's see, 6.1. Okay, this one makes sense. But that's square root of 38. Oh, no, that is that one. And then this one also seems to make sense, but that goes with this number. So that's kind of a trap. So it must be C, but let's double check why this one also works. This number says 6.2, but then past that, 6.28. So that's almost to 6.3. Which is why this one makes sense. So C is the correct answer. Number 25. Haley was attempting to classify the two groups of numbers below. Which titles will be most appropriate? Now this is pretty easy. This one's terminating, or this one's terminating. It's a nice integer. This one terminates, this one repeats, no problem. That's all rational. Here, all of these, including pi, irrational, 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 especially with the dot, 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 irrational. Like if you put this in your calculator, 2 shift x squared, that's going to be 1.41. It keeps repeating, or it keeps going and never stops and never repeats. Same thing with that one. So this is irrational. So group 1 is rational, number 2 is irrational. That makes sense. Number 1 is rational, 2 real. Actually, all of these are real numbers. Okay, all of these are real. So that it doesn't mean that only this is real. All of them are real. So B is wrong. Number 1 is real, and then 2 imaginary. No, real numbers, imaginary numbers is in a whole other category. We never learned about that. You're going to learn that when you guys get into another grade, so you don't have to worry about that. Whole numbers, no, this doesn't have just whole numbers. It's got other numbers that are not whole. So, yeah, these both have square roots, so A makes sense. Rational, irrational. Okay, so that's number 25. Now we're going to go to page, what page was that? Okay, hold on, let me pull back here. Oh yeah, so page 14 has to do with relationships and functions. We're going to go to page 15. The homework was, here's page 15, the homework was to do all of 1 through 8. So if you remember, function, okay, if you want to pause the video, or you can go grab a highlighter, or just actually you can I'll use a highlighter. So if you have a function, it's a relationship between two variables where every input has exactly one output. That means no repeating x values. Okay? No repeating x values. And then if you look here, we'll talk about rate of change in class, but for function, let's go to page 15. So it says here to describe the relationship in the table. It's definitely a relation, okay? It's not D then. And so then we go back and see, okay, are there any repeating x values? No repeating x values, which makes it a function. So it's actually both. A function is already a relation, so the answer is C. All right, now let's go to number 2. Which of the following set of ordered pairs again is a function? That means no repeating x's. Then I would like highlight or look at only the x values and make sure it doesn't matter what the y's are doing. Who cares about the y values? Just look at the x. This one has all repeating x values. That's not it. This one has none, so it's probably this one. This one has these two, so it's not a function. This one has a repeating 2, so C has to be the correct answer. Okay, number 3. Which one, now I would highlight, does not. That means there's 3 that are functions. So this is where you use the vertical line test, right? Remember that? Vertical lines go this way, up and down. So if I draw a vertical line here, 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 it passes because it only intersects the line one time every time. Okay, over here, pass, 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 pass. So this is a function. Okay. Over here, pass, 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 pass. No matter where I draw a vertical line, it intersects the graph one time. Here, maybe it passes right here, just hits it one time, but here, 2, here, 2. This fails. So this is the one that's not a function. Again, if I'm going too fast, you know that you can always rewind the video and do start over and listen to the explanation. Okay, which of the following relations does not represent a function? So that means 3 of these do. 3 of these, we're looking for one that is false, 3 of them are. So let's look at the x values. Okay, this one, this one, this one, this one. Okay, that's true. This is a function, but we don't want that. Now this one, remember when we talked about the x and y values, okay, that there's no repeat, like they don't have weird x's or weird exponents, right? So this is actually a function too, so we don't want that. Multiplying each input by 10 to produce an output. So I want to try an example like that. Let's say the input, like a 1, and then like a 2, and then maybe a -1, and maybe a 7. Now multiply that by 10 to get the output. Let's see. So if I multiply that by 10, that gives me a 10. 2 times 10 is 20. -1 times 10 is -1. 7 times 10 is 70. That doesn't necessarily mean that it's not a function, okay? We can have a function that's not going to have any repeating x values. So multiplying, the act of multiplying by 10 doesn't make it not a function, okay? Now here we have repeating x values, so it's definitely D. D is the one that's false, but this one also it can be a function, so that's out. Number 5, choose the best description of the relation shown below. Okay, now this is talking about functions, so I'm going to look at the x values again. So the relation is a function because every input has exactly one output. That makes sense. Each relation is a function because every output, no, you should always start with input, okay, because that's your x value, which means you don't repeat it. So it can't be this one. The relation is not a function. Actually, it is, because there are no repeating x values. It is impossible to tell. No, it's possible because we have our ordered pairs, and we can see the x values, and it is a function because every x value has exactly one output, which means x doesn't have more than one output. If it did, it would repeat. So there you go. Input is x value, output is y value. Okay? So number 6, which equation shown shows a linear relationship? Remember, look for exponents of 1. Now this one, definitely not linear, definitely not linear. And if the x is on the bottom, definitely not linear. So nonlinear, nonlinear, nonlinear because of that. But this is definitely linear, so it's A. Number 7, which one shows a linear relationship? Literally, it should be just a straight line. This one broke, so this is not a line. This one broke, but this one just continued. So whatever looks like a line, then that's your answer, okay? And then last, number 8, choose the best description of the graph. Linear, it's definitely not linear because, again, like we saw here, it's nonlinear, it's both linear and nonlinear. Well, we'll have to see. Nonlinear because each segment has a different slope. I would say yes, okay? Although these slopes are the same, but they're not all the same. Both linear and nonlinear because it is made up of straight line segments, but it is not a complete straight line. Okay, neither linear nor nonlinear because it is made up of a straight line segments, but is not a completely straight line. I need to think about that one. Okay, let me see again. Nonlinear because each segment has a different slope. Well, but these two right here have the same slope, so because they're going down the same amount and over, down the same amount and over. So I'll think about that one. Both linear and nonlinear because it is made up of straight line segments, but is not a complete straight line. This part is true. Let me see this one. Neither linear nor nonlinear, because it is made up of, it has to be one or the other. So this is just one or the other. It can't be that one. I want to lean towards B, but honestly, I'm going to look at the answer keys just because I'm not sure about the wording of this question. So let me take a look real quick. Number 8, this one has to do with, what page am I on? Page 15. Number 8. The answer is B. Yeah, that makes sense. So nonlinear. So it's either linear or nonlinear, and this is a good review of that. This is not linear. Not linear, not linear, not linear, but this is linear. Okay, we can't have a mix of linear and nonlinear. Okay. All right, so that's the end of that. So your homework was to do 1 through 8. Okay, all of 1 through 8 on page 15. And then you were also supposed to do those 2 problems on page 10, numbers 24 and 25. Okay, so this is the end of the video.